corrected. Stand corrected. Vector A, it is still flossing the magnetic field. We got a wire that's being pushed up and down here. I'll just hold it off to the side. It'd be pushing up and down between the lines. So flossing the field, that is not cutting through magnetic field lines, but by going up and down. This one here, going in and out of the page, is still going to floss in between the field lines, therefore not cutting through field lines, not encountering a change in magnetic field, and so no current gets induced in that wire. This one here, if it's moving in vector C, is going to be moving in this direction. And you can even tell by the cartoon, we're not flossing the field anymore. We're bumping into a change in magnetic field. So that's the way the artist has tried to illustrate this. We're saying that the force is in this direction. And if it's forced in that direction, while the magnetic field is orienting externally from north to south, and we can see these vector arrows here going from north to south, is this current going to go into the page or out of the page? And think to yourself, am I using a right-hand rule or a left-hand rule? Lenz's law. How many people say into the page? How many people say out of the page? Let's do a revote. How many people say into the page? How many people say out of the page? Oh my gosh, like 2 people voting either way. Let's try this out then. All right, so here's my left hand. I know it's my left hand because I have a letter L written on it, because I always forget. Let's see. Magnetic field is downwards. And I got to get my palm somehow pointed this way. Yep. Palm pushing this way. Let me see if I can. Oh, can you see that my thumb is pointing downwards? This is such a contortion act. You try to do it yourself. This current is going into the page. But don't forget to use your left-hand rule. Okay? It really is going into the page. If you got it coming out of the page, I can almost guarantee you used your right hand. Yep.
Why did you do left hand again?
Because left-hand rule, or Lenz's law, really it's called Lenz's law, is that generator principle, that idea that if I have an input of a action force on a conductor, or I push a conductor through a magnetic field, or I cause a magnetic field to change around a conductor, then the flow of the current that's induced is going to follow a left-hand rule. Or at least it'll be the opposite of the motor principle. Okay? Yeah.
Will I get a question? Would it tell you?
No, the question won't say use the left-hand rule. The question would say, what direction would the current be induced to flow? Yeah. So, and the difference is with a motor principle type question, what direction would this conductor be forced to move in? So it really is like an input-output difference.